Hello, everyone. I want to thank the organizers for giving us the opportunity to present here our data. And I'm really blessed to show you this new immune molecular pathway of neuromodulation that we have found. So maybe, at least me, I already experienced some stress today, and when this happened to you, normally you activate the HPA axis, which is going to release glucocorticoid, and also there is going to be an activation of the sympathetic nervous system, leading to norepinephrine secretion. And I don't know you, but in my case, I recall several times where I was super stressed, and this was affecting the development of some herpes in myself. And also, you can recall maybe some other infection that get worse when we are stressed. So basically, there is another branch of the autonomic nervous system that seems to be that is counterbalance this stress-induced branch. That is the parasympathetic one that gets activated when we do some stress relief strategies such as meditation. And this is why we are releasing acetylcholine. So basically, our question was, there could be any kind of link between this stress induction and this immune response, and if so, it can be this particular immune cell that are called dendritic cell. And why we thought about that? We thought about that because what is the evidence is indicating is that these dendritic cells are at the core of the development of the immune response. And this is because they are able to integrate several and different environmental cues, and then they are providing the naive T cell not only with antigens, but also with this important contextual information. So this is why our initial hypothesis was that maybe the dendritic cells are at the core of this intersection between the stress and the immune system by integrating several autonomic neuronal signals. So the first thing we did was to purify the two main subsets of dendritic cells from lymphoid and non-lymphoid tissues, in this case the spleen and the skin. And we look for the neuronal receptor for this neurotransmitter named norepinephrine, epinephrine, and acetylcholine. As you can observe clearly, the beta-2 adrenoreceptor was the most representative in both tissues. And not only that, the dendritic cell type 1 that they were already introduced by the last speaker, they were expressing more beta-2 receptor than the other dendritic cell, the type 2 in this case, and this was true in both lymphoid and non-lymphoid tissues. So the next question we asked ourselves was whether this was only a random finding or this has some kind of implication regarding the dendritic cell function. And to talk about dendritic cell function, I need to guide you a bit that the dendritic cell, when they interact with the environment, they can be modulated at several different levels. One can be the production of cytokines and chemokines that are going to condition the naive T cell to generate different subtype of T cell adaptive response, but also can be at the level of the co-stimulatory molecule expression that is also important for the priming, or these two processes that are interrelated, that is their capacity to present antigen, and for that they need to be able to migrate to the lymph node. So the initial experiment was, of course, purify dendritic cells, activate them with some pro-inflammatory stimuli in the presence or in the absence of the beta-2 receptor agonist. After that, we measured dendritic cell function at several levels, as you can observe, for example, at the level of co-stimulatory molecule. When you provide with some inflammatory stimuli, you have an upregulation of this molecule that is dampened when they are in the presence of the beta-2 receptor agonist, indicating that this signaling is playing an inhibitory role for the dendritic cell response to an inflammation. So when we move in vivo, basically we did two different approaches. We resemble the sympathetic nervous system activation by providing norepinephrine, or we eliminate this input by providing the neurotoxin 6-hydroxydopamine. And when we did that, by the norepinephrine intradermal administration, what we observed is that the dendritic cell in the skin, they were producing less cytokines in response to inflammation, and they were migrating less from the skin to the skin-draining lymph node. And in the other way around, when we eliminate the nerves in the skin, we observe that these were producing more cytokines in response to the inflammatory stimuli, although this was not affected the migration from the skin to the skin-draining lymph node. And both results together indicate that the sympathetic nerve-derived norepinephrine can inhibit the dendritic cell response to the inflammation. To validate this data and also to provide more insight in the case of the sympathetic nervous system modulation of the dendritic cell, we took the advantage of this DREAD system that is letting us to activate the sympathetic nerve or inhibit them by providing a synthetic ligand. So what we did is to provide this synthetic ligand systemic. As you can observe, this was validated by the elevated level of the norepinephrine in the spleen upon the administration of the ligand in the Cree model, and this correlates with a reduction in the cytokine production upon inflammation. And on the other way around, when we analyze the inhibitory DREAD and we provide the synthetic ligand, we observe that this dendritic cell can produce more cytokine in response to the inflammatory stimuli. Altogether, these two approaches, by using the DREAD system, validate this data that seems to be that the activation of the sympathetic nerve is sufficient without any other stress to inhibit dendritic cell function. So with this data, we decided to generate a specific Cree model just to target dendritic cell adrenoreceptor beta-2 expression. So for that, we took the advantage of the XCR1, as the previous speaker commented. It's really specific for the DC1. As you can observe here, it's only targeting the expression of the receptor in this subset and not in the other, or other immune cells. And when we analyze the dendritic cell coming from this animal, when we eliminate the beta-2 signaling in this dendritic cell, they produce more cytokines in vitro in response to inflammation, and this was also true in vivo in the skin. The dendritic cell type 2 were producing more cytokine, whereas the dendritic cell type 2 were not affected in this genetic model. So indicating that all the effect that we are observing previously is dendritic cell type 1 intrinsic. So finally, we decided to move to an in vivo model to provide evidence whether this inhibitory signaling was playing a role in any kind of important model. And for that, we decided to move to the tumor development. And the reason why is because the dendritic cell type 2 has been reported essential in preclinical and clinical models. So when we provide a melanoma orthotopically in the skin of the wild type and the dendritic cell 1 beta-2 knockout, as you can observe, the one without this inhibitory signaling pathway, they can control better the tumor. And not only that, also the composition of the melanoma was different between the two. In the case of the deletion of this neuroinhibitory axis, the tumor were composed with less exhaustive T cells, already commented by the previous speaker, and also less regulatory T cells, indicating that, of course, this norepinephrine beta-2 on DC1 neuromodulatory axis can have an impact in the dendritic cell 1 mediated immune response, and in this particular context, to the anti-tumoral immunity. So I just want to take the last slide to thank all the people involved in this project, especially my supervisor, Enrique Vega Fernandez, all the people, of course, in the lab, but particularly Raquel Silva, that is part of the team, is doing the PhD. Also, the master student Miguel Patricio, that was doing most of the migration studies, and Maria Betancourt, that joined recently as a technician on the project. And of course, Bruno Rasposo, Inés Godinho, and Angel de Ribeiro that are doing all the colony management and all the lab administration staff that is essential. I also want to mention the technical units and facilities from the Foundation, and also our neighbor labs that are providing us with a lot of advice and tumoral cells, all the funding agencies that are providing the money, and thank you all of you for your attention. And if you have any kind of question, discussion is welcome tomorrow in the poster number 13. Thank you very much.